Hello everyone. Let us continue our lesson acid bases and salts. So in the last video we have discussed indicators. Now, indicators are those solutions or substances which can change their color when added to any acid or a base. Now as such indicators are of two types: natural indicators as well as artificial indicators. The natural indicators are turmeric, China rose, and the litmus papers, red as well as blue. Whereas artificial indicators are phenolphthalein and methyl orange. So as such, when these indicators are being added, okay, when these indicators are being added, the acids or the bases, they change their colors. Now as such, you can see over here related to the indicators. Universal indicator is nothing but the pH scale, what we have discussed previously. Now, as such, when we add this phenolphthalein, which is an artificial indicator, the acids are colorless, right? The neutral substances are also colorless, but the alkalis, that is, the bases change pink in color. Whereas in methyl orange, the acids change red, neutral are colorless, as well as the bases are also colorless. Whereas blue litmus, the acid changes into red, the neutral as well as the bases remain blue. There is no change. Similarly, the red litmus, the acids are do not change, neutral also do not change, but the bases change into blue in color. So that is related to the change of colors. Now as such, now these are the substances. Turmeric, you know, fine. Then red litmus and blue litmus papers. Then these are the lichens. If you can recollect the definition for lichens, lichens are nothing but they are the combinations of algae and fungi. Now, as such, the indicators, this is the China rose, hibiscus flower, which I was talking about. Hibiscus, this is an acid indicator as well as the base. So, as such, this is methyl orange. Now, we'll move on to the next slide, wherein we discuss about salts. Now, as such, what are salts? The salts are neutral substances produced from the reaction of an acid and a base. Now, what are salts? If you can recollect, we have learned in the properties of acids and bases, stating that when acid and a base react together, that gives rise to a salt. Now, as such, here sodium hydroxide is a base. For example, if you are taking sodium hydroxide is a base and hydrochloric acid is a acid. Now when these two react with each other, it gives rise to a salt, which is sodium chloride as well as the water. So this is something called as a neutralization reaction. So addition of a base and an acid gives rise to a salt. Now as such, a little more about neutralization reaction. Now these neutralization reactions are those which we come across in our daily life. You might have seen, you might have already used it also. Usually we get this from your grandparents or your parents. Now as such, these neutralization, some of the examples of our daily neutralization reactions are, if at all there's an ant sting, right? Then you feel that pain, okay, pain in the place where the ant has sting, okay, introduced its sting. So sometimes it is a pain and sometimes it gets swollen, that part. So there you can usually neutralize that reaction by just rubbing baking soda. Then in the treatment of indigestion, this I think most of us are aware of it. So using hydrochloric acid and milk of magnesia. So this can be treated by taking milk of magnesia. Then in the treatment of soil with slaked lime, fine, to neutralize the soil, right, the salts present in. reactions or the compounds present in the soil to neutralize the soil. So they use slake lime. Then in the treatment of sewage waste, if you remember, we have learnt about water treatment in the previous classes. There, to neutralize the reaction, we use calcium hydroxide, right, to reduce or neutralize the acidic contents from the industrial waste. Then, in treatment of acid burns, by mistake in the laboratory, if you have come across an acid, if you have touched or the acid has fallen onto your skin, so that burn, okay, with diluted solution of baking soda, that can reduce the pain of the acid. So that is about your neutralization reaction. Then coming to the end of the topic, that is the types of salts. We have learned about salt, how is a salt formed. Then we have learned about neutralization reactions. How is that we can neutralize the reaction by using various products. Now coming to different types of salts. Now what are the different types of salts present or we come across? They are acidic salts, basic salts, and neutral salts. Now, what is the meaning of acidic salts? In acidic salts, there is a strong acid reacting with a weak base. That gives rise to acidic salts. Here, the acid is strong enough, so that results in acidic salts. For example, ammonium chloride and aluminium chloride. Now, coming to basic salts, these are the strong acids. Now, salts. Now coming to basic salts. Basic salts is a reaction between a weak acid and a strong base. So examples of these are sodium carbonate and sodium acetate. Now whereas coming to neutral salts, that is strong base and strong acid reacting with each other. Just now we have seen is in strong base sodium hydroxide, whereas reacts with hydrochloric acid, that is also a strong acid. That gives rise to a sodium chloride or potassium nitrate. So these are the three different types of salts: acidic salts, basic salts, as well as neutral salts. Now, what are the properties of salts? Now, coming to the properties of salts, most of the salts are soluble in water. So that's the reason we call as water as a universal solvent. Then solutions of salt act as a good conductors of electricity. So as such here, when you add salt, that transforms into a good conductor of electricity. Then salts have different colors like white, blue, green. They have different colors. Some salts contain water molecules trapped inside. So they are called as hydrated salts. So when you dissolve the salt in water, so these water molecules they get trapped in between them. So such salts are called as hydrated salts. So one such hydrated salt is nothing but copper sulfate solution. Okay, copper sulfate solution. Then two or more salts that crystallize to form a single substance are called as mixed salts. Right? Two or more salts mixed together. Right? Like for example, here we have taken potassium sulfate, aluminium sulfate. When we mix these two salts, okay, these two salts mix together, okay, that crystallize to form a single substance, and that single substance we call it as an alum. So that is what is alum. A mixture of potassium sulfate and aluminium sulfate gives rise to alum. Then lastly, what is the use of these salts? How can we use salts in various purposes? Sodium chloride, that is a common salt. There's no need of any explanation for this. Used as a cooking and as well as preservative. Then sodium carbonate. Sodium carbonate, also called as washing soda, that is used in your detergents. Then sodium nitrate. This is chili salt petri, right? As fertilizer, food additive in making gunpowder also. Then coming to sodium bicarbonate. which is your baking soda, used as your baking industry agents in your bakers as well as in your houses also, in medicines, and also used in fire extinguisher. Then lastly, coming to calcium carbonate, limestone, commonly called as limestone, used in constructions, purification of iron, and also a dietary supplement if we are suffering from calcium deficiency. So that's all related to acid, bases, and salt. Hope so. You have any doubts related to this? We will be discussing in the classrooms. Okay, beta. Thank you. Have a good day.